Which is better for my form, PureScript or TypeScript? Sometimes in forms, your current set of available options depends on your previous selection. In this video, I'll go through my solution for my form in PureScript and in TypeScript so that you can decide for yourself which is better. All right, so let me introduce you to this form. This is a form for a tattoo artist. It's a real life scenario. Basically, we're wanting to ask the person who's filling out the form to identify which part of their body specifically they want to tattoo. So in the case of like arm, once you select it, you get a sort of more specific option that you can choose, like your left or your right arm. Let's say we choose the left arm, and then we can get more specific, like bicep, tricep, elbow, wrist, whatever. So here we have basically a group of inputs that they're kind of all dependent upon each other. And depending on which one you choose, let's say leg, we go with the leg route, then we can choose like the right leg and then the hamstring, whatever. So this is a way of basically a technique with forms of just sort of giving out the information incrementally. If I had to display this all in one form element, it would just be a massive list, and in a moment I'll show you the data structure behind it, which is quite large, and honestly it would just be super overwhelming. So we give it to the user little by little. So when I first conceptualized this, the solution for this, I had this is what I had kind of imagined it would be. So we have at the top level we have a list of options: arm, leg, torso, head, hand, so on. And then you have beneath it a bunch of sub options. Like, so once if you select arm, you can choose the shoulder or forearm or bicep or elbow or so on. And what I have here when I conceptualize the problem is like a tree structure. You have a tree with each option presenting an array of possible subtrees that you could narrow down on. So what I had to do was come up with a solution basically that rendered form options that could be represented as a tree of arbitrary depth. So that's what we're getting into. So let's take a look at the code a little bit, because I want to show you how it is in the PureScript code and then how it's done in PureScript or in TypeScript. So here's how I represented the tree. It's a data type of tree of something, and that tree of something is either a leaf of something or a branch of something. And that branch also has a non-empty array of subtrees. So that's what that represents there. And specifically, when I went and crafted the tree for this input, it's a tree of radio input node. And radio input node represents like the inputs for a radio button. So we have here a tuple. So in that radio input node, we've got the inputs to the radio button that will render, which is like the label, the validation function, whether it's required, and the set of options. So anyway, we could go deeper, but I think you've got the idea. In reality, it looks something like this. So like here's a branch, and it has a branch of something, and that something in this case is radio input node. So that's what this is. It's a list of the label, the validation function, whether it's required or not, and the set of options. And then it has a subtree, or it has an array of non-empty subtrees. So anyway, that's how it's represented. And let's take a look at this function. This is like a core function that I made for gathering. Like once you make a selection, you have to find a way to sort of navigate that tree, and based on your selections, gather all of the various radio input nodes that you're going to render. So it takes in a set of selections, maybe, if there is any. It takes in the the tree that you are going to navigate. So this is a tree of radio input node, and then it outputs an array of radio input nodes. And this is the array of inputs that will render in the application. So actually, I'll go take a look at the render function. It's pretty simple. Takes in levels, radio input nodes, I guess, and we just map over it and we render the radio input in the slot that we have defined. We render the radio button, and it's got like label validation function, whether it's required or not, and the set of options. And so I won't get into the handle action, but this is basically how you do like state computations. You take in an action and you do some computation. So in our case, it's like you handle the selection from the child and you update the tree. Tree is what renders is what invokes this gather radio input nodes and makes it available as levels in our render function. But I want to just focus on this. This is our core function, okay? Because this is the mechanism by which we get a set of inputs, a set of radio inputs that we're going to iterate over to render. So this is really like the core function. And it's really nice. It's about 15 lines of code. Yeah, it's about 15 lines of code in the comments, so maybe 14 lines of code. It has a little bit of recursion in it. Here we are. I'll just go over it a little bit, I guess. So we're getting the first selection. That's X. This is like the first selection in the list of possible selections, and based on that selection, we're finding in the set of options the index, and then we're using that index to find the appropriate subtree to iterate over next. And if there are no other options, this is what XS is. There are no other options, then we just recurse. We add that there's no other options, and we pass the subtree. Otherwise, we just we continue navigating the tree. So this is like 14 lines of code. Simple. I mean, I don't know if it's simple. It's elegant, I guess I would say. These represent, just a little introduction to the language. These all represent case statements. So if I happen to, like, this is the terminating case. Basically, once we're at a leaf, we know that we're done iterating through the tree. If I happen to forget to specify a case, I get a compiler error, which is nice. It's telling me I missed some case, or this case, it'll tell me specifically that I forgot. The nothing case. All right. So this is pretty good, and this is the core functionality behind the how we determine the various steps of the form to render, the various dependent radio inputs based on the user selection. Now, how would you do this in TypeScript? Okay, so let's go to our TypeScript playground. And I reconstructed this in TypeScript, this basic core functionality, gather radio input nodes. And I ran a few cases just to make sure it was working. So here the selection is like arm, left arm, bicep. And so it renders, let's go to the top. Wow. Oh, we'll just have to refresh. Yeah, so this renders like the root, which is like which part of your body is being tattooed. So that's the first element that gets rendered, radio input that gets rendered, and then it also renders which arm is being tattooed, and then which part of your arm is being tattooed. So if a user has selected, so it displays those three because of the user selections, and that would represent like a complete selection. You'd navigate all the way to the leaf of the tree. Yeah. So anyway, these all works. If you don't have a selection, then you just get the root only. That makes sense. So like when you're coming into the form, you want to make sure at least the root is rendered. The root of that radio selection is rendered. All right, so let's go take a look at and see how this works over in TypeScript land. So here I've constructed similar code, but in TypeScript, and it's represented. The tree in TypeScript is represented as a typed union, and you have to add this like kind so that you could do like a switch statement on the leaf or the branch. So let's pick apart, like it's honestly not that bad. The solution is not that bad, but I want to do a little comparison, and I'm going to pick out a little bit. So I would say the first thing that could have gone wrong here, or the first thing that I will note that is I think is a deficiency of TypeScript. I mean, I understand TypeScript is a superset of JavaScript, and there are some compromises that are there so that you can so that it can be added to the language, like incorporated into the language easily. But one thing I don't like is this exhaustive check. There is no true exhaustive checking in TypeScript. You have to specifically set the config to be strict, and you have to remember to use the never keyword. So for example, it would have been perfectly valid for me to code this application like this: tree.value, and basically not match on the leaf. I could have said like, okay, if we're in the branch case, then we do this otherwise, because what other possible case is there? There's leaves or branches, and that all works fine. And probably you're never going to have anything other than a leaf or a branch, but you could at some point add another case at which point this would fail at runtime, because you're not using that special never keyword right here. I would say the other thing I want to pick apart a little bit is like null checking. We know that null is bad, and here we still have to handle the null or undefined case. Like even in this deconstruction, you have to handle undefined or like null. And of course, like you could imagine a case where head is falsy, and instead of doing a specific undefined check, that you maybe had like done something a little looser, like if there's no head, it still works. But I mean, what if your selection was actually like 0 for some chance? Like it's possible, it could have happened, that the value is 0. Anyway, the other thing I'll comment on is the generally speaking, there's just more lines of code. So taking a look at this, 384 to 410, that's 94, 104, 26 lines of code with any comments? No comments, just 26 lines of code. I mean, maybe I got that wrong, my mental math there, but 27 maybe, I don't know. But when we go look over at the PureScript code, we have 14 lines of code if you remove the comment. Of course, the generated output is a little bit more verbose, but like in PureScript, it's like 14 lines of code. So it's a little bit more concise. It's a little bit more like to the point, concise, less verbose, less manual handling, less pitfalls, right? You don't have to in PureScript do these additional checks to make sure that, or there's less pitfalls, right? I mean, this is crafted really well, but it could have easily been Like, for example, you could imagine that someone might not even do a check for -1 on the index, right? Like, that's totally possible that is that could have been that could have been forgotten or omitted, and it wouldn't be wrong. It would just be it wouldn't be wrong in the sense that like it might possibly work all the time. However, you do need to account for those edge cases, right? Like, what if you can't find the selection in the input? What if you can't find the correct subtree? So you need to think of those cases, and I would say in TypeScript you really have to be more careful, and I think that's why you see more lines of code. It's like double the lines of code, probably due to just like the various like extra checks that you need to do, right? Whereas this is built right into the type system, right? Like if you find the index, or if you use find index, then you have to handle the case that there was no index found. It wasn't found in there, for example, or you're looking for the subtree, right? What if you don't find it? What if you don't find the subtree at that index? You have to handle it. So it's easy not to handle it in TypeScript, right? And it's allowable. It'll compile. You'll just get errors at runtime. So which is better? Let's answer the question. Which is better? I think it's hard to say. Really, I'm coming to realize that when it comes to strongly typed languages, communities like PureScript versus JavaScript and TypeScript, it really comes down to what you value the most. If you value robustness and you don't mind going slower, then PureScript is the language for you. But if you just want a little bit more safety than JavaScript, and you still want to go fast but not be as robust, still have errors at runtime, if that's acceptable to you in terms of values, then TypeScript might be the correct solution for you. For me, as I get like older and have gone through like the 2000s, the 2010s, having been a developer in JavaScript, and just gone through the immense churn of that community, as packages are just like, everything's changing so quickly and packages are being published so quickly. And then come over to a community like PureScript, I see it's a lot slower and like stabler and smaller set of packages and way, better quality packages. I've just come to accept that with these more mature languages, things go a little bit slower, but they are more robust. So it just comes down to really what you value more. Both PureScript and TypeScript can adequately represent this complex form state, but I guess it just comes down to values in terms of what you value, and whether or not you value a robust application at the cost of being slower. So anyway, thanks for joining me in this little example. I hope you enjoyed it. And if you want to see more of these types of comparisons and deep dives into specifics, then make sure to like and subscribe and follow me on the journey. Bye now.